All right, so now we can start finding the derivatives of the other trig ratios. So tan, cotan, etc. All right, so we can actually do this by breaking everything down in terms of sine and cos, right? So let's find these. So let's say if we had y is equal to tan x, we could rewrite that right off the bat as sine x over cos x. Well, now if we find the derivative of this, so y prime, this seems like this is the quotient rule, right? I'm dividing. So that would become cos x times cos x plus sine x times sine x all over cos squared x. Let's go back through that. Maybe make sure you guys saw what I did there. So if this was, g times f prime minus f times g prime all over g squared. Okay, well, g was my cos. F prime was my derivative of sine, right, which is cos. And then f, which was, so this would have been minus to begin with, right? So this was f. And then g prime was negative sine, right? That's why this became a plus, because it was minus and negative, so plus. And then that was our g there. Okay, so hopefully you guys can see that. So now from there, well, what we have going on the top here, I've got cos times cos, that's cos squared, plus sine times sine, that's sine squared. So this is really cos squared plus sine squared. Well, that's one of our identities, which is 1. So this is 1 over cos squared x, otherwise known as secant squared x. So there you go. There's the derivative of tan is secant squared x. That is on your formula sheet, by the way, too. You won't have to do that every time, but yeah, so that's how we find that one. So now cotangent. So cotangent will be similar. So this would be y is equal to, now this would be cos over x instead, or cos x over sine x instead. So then that would become negative sine x times sine x minus, and then this would be cos x times cos x all over sine squared x. Now if you want to write out the rule, or the quotient rule again, and see if that makes sense, go for it, right? Okay, so then rewriting this would be, well, I'm going to factor out this negative right now. I'm going to do this in one step. So this would be negative, and then we'd have sine squared x plus cos squared x all over sine squared x. And again, sine squared x plus cos squared x, that's 1. So this becomes y prime is equal to negative 1 over sine squared x, which would also be known as negative cosecant squared x. All right, next one. So what's the derivative of cosecant x? So cosecant, so let's rewrite this as y is equal to 1 over sine x. And then one more time, I'm going to write this as sine x to the negative 1. Okay, so now if we take the derivative of this, it would be y prime is equal to, now chain rule, right? I'm going to bring down the negative 1 times, and then keep the inside the same, and then apply my derivative to the exponent here, just so minus 1, so that's negative 2 now. And then don't forget, we also have to take the derivative of the inside. Chain rule this out, so that would be times cos x. And that's pretty much it. So now let's just clean that up. So y prime is equal to negative cos x over sine squared x, right? I just applied that negative and the cos on the top, and then the sine x went down to the denominator. Okay, so there you go. It could be written that way. Or we could split this up a little bit too. We could write this a little different as negative cos x over one of these sine x's. So sine x times 1 over sine x. And then these are identities, so we can rewrite those as well. That would be negative cotan x times, I'm going to put these in brackets, times cosecant x. And there is our derivative. Okay, last one, so secant. So secant, we're going to rewrite this as y is equal to, I'm going to skip a step, this would be cos x to the negative 1. Okay, so then taking the derivative would be, so y prime would be negative cos x to the negative 2, and then times the derivative of the inside would be negative sine x. So y prime is sine x over cos squared x. So then splitting this up like we did in the last one would be sine x over cos x times 1 over cos x. So y prime would be equal to tan x times secant x. There, we have all of our derivatives.